All right, welcome to 8.3 day 3. Before we get going, I just want to do a review one. Usually on the test, these direct or inverse variations kind of trip students up. So see if you can figure out which variation it is, direct, inverse, or neither. And then if it is a direct or inverse, see if you can get the right equation for it. Okay, direct variation is y equals kx. So it's just a constant times x, and an inverse is equal to y equals some constant divided by x. As far as figuring it out in a table, I don't know a great way to explain this to you, but I think one thing you can look for is like if they both go up together or down together, that's going to be that's going to be direct over here. They both go up or both go up together, both go down together. If one is going up while the other is going down, then it'll be an inverse variation. Okay, so we could look at this one as x is increasing. It looks like y is actually decreasing, getting smaller. So these ones are increasing, these ones are decreasing. So our guess is it's going to be inverse. Okay, and so what we can kind of test is if you multiply them together on an inverse, you should get the same thing. So this is 3/10. This one's 3/10 because it could be neither technically. So I'm going to keep multiplying them together. I think that's 3/10. And then, oh boy, I would have to use my calculator there, but I think that is going to be 3/10 if you multiply those together. So as far as the equation goes, we can say when we multiply x and y, we get 3/10, and that would be it. That'd be a fair equation. If you want it in traditional form of y is by itself, you would divide both sides by k. So you'd have y equals 0.3 divided by x. Okay, and that's at which point k, the constant, would be 3/10. So that's kind of the more traditional one, is where you have k over x for inverse. So just to be clear, that one's inverse. All right, and then this one, they're going up together. So as x gets bigger, going here, y also gets bigger. So this one we're going to guess is direct. We should still probably check. And the way you check a direct is you divide the pairs and see if it's a constant. So if we take 3 divided by 1, check, right, divide these, y divided by x. 6 divided by 2 is also 3. 15 divided by 3, sorry, 15 divided by 5 is also 3. And then the last pair, 16 divided by 8, is also 3. So basically, when we do y divided by x, we always get 3. So again, that's a valid equation. Or you could multiply both sides by x and say y is equal to 3 times x, which is the more traditional way to do a direct variation, is just a constant times x. So this one would be an example of a direct variation table. Okay, so I want to just do a couple more graphing ones with you from, this is section 8.3, and this is the big picture of it. So you'll factor the numerator and denominator as needed. Vertical asymptotes or holes are when the denominator is equal to 0. And then the horizontal asymptote, you'll use that chart, that MN chart, right? And then that chart will be given you on the test, by the way, so you don't have to memorize it. And then you'll plot the asymptotes and graph the rest of it with your calculator. So as always, have out a graphing calculator for this lesson. Okay, so there's our chart for horizontal asymptote. Again, hopefully you've got it jotted down somewhere or reference it on the notes online. Okay, so we want to sketch a graph here. And the first question is like, when is this denominator 0? All right, and so to figure that out, we want to factor it. All right, so I'm actually going to have you pause the video and try this, actually. I should have said that first. Try it before continuing. All right, so this factors apart to x and x for the x squared, and then multiply to 4, add to 4. That would be positive 2, positive 2, so everything's positive here. And so if we set those to 0, we actually get x equals minus 2, and we kind of get it twice. But suffice it to say, there's going to be one break here at x equals negative 2. So we got to figure out, is that break a hole or a vertical asymptote? And the check is, does this x plus 2 cancel with a factor up top? And in this case, there's no matching factor, so it's going to be a vertical asymptote. Right, so we're just going to draw in a vertical asymptote at x equals negative 2. Okay, so there's our vertical asymptote. No holes, all right? And then the horizontal asymptote, again, we're going to use the chart. So I'm going to look at m and n. So m in this case is 1, highest exponent up top. N is 2. So we have m less than n, and on the chart that'll say the horizontal asymptote is y equals 0. Okay, so on the y-axis here's 0, and so our asymptote is just right, it's basically the x-axis right here, because y-axis of 0 and then go horizontal from there. All right, so we plotted y equals 0, which is again just the x-axis. And now to figure out what the graph looks like, I just got to type it in. And just another reminder, make sure you surround it in parentheses. I go back to the original one and just enter it in that form. So in the y equals, enter it in there, make sure to use parentheses. X minus 1. Okay, and so I know where my asymptote should be, so I'm going to graph it now quick and see if I get my asymptotes kind of where I'd expect. So I do have one along the x-axis here, or the y equals 0 line, and then here's the one at -2. You can kind of see the vertical one right there. So when you transfer it over, just sketch it as best you can. I always struggle on this little writing tablet to draw it, but I draw something like that, and then I think it goes something like this, something like that. And this part is kind of strange to me a little bit, but I think it might actually cross this asymptote, which kind of defeats the point of the asymptote, I guess, defies the definition because it should never touch it. But I think it's kind of asymptotic, if that's a word, right here. And then also as it comes back down, it's kind of asymptotic going back down that way. So it's a little bit confusing to me there, but on the test, I'm mostly going to look that the asymptotes are plotted correctly, and then you just got the graph sketch. All right, let's do one more graph one. Okay, so pause the video, give this a shot as much as you can before continuing. All right, so we know there's a break at 4. So if we set the denominator to 0, we're going to have a break at 4. We want to figure out, is that a vertical asymptote or whole? To do that, we're going to factor the top. So this is square minus square. So we have x and x for the x squared. And then to make -16, if we use -4 and +4, that'll multiply to -16 and give us like 0x in the middle. So it's +4 and -4. All right, so the whole point of that is to say, now that we have it factored, if you look, this x minus 4 cancels out. And so because it canceled, the solution that came for it, or the break that came from it, that 4, is now a hole. Right? Instead of being a vertical asymptote, we're going to draw a hole in the graph. Okay, so I'm just going to make a mark here, and I know that there's going to be a hole. And please note that the hole isn't right here on the x-axis, it's wherever the graph is. So if my graph happened to look like that, I would go down and draw the hole at x equals 4. I don't really know what it looks like yet, but that's the idea, is that it's not right here. It's, go to wherever the graph is, find the x of 4, and then draw a hole like that. Okay, so we got it marked at least for when we do draw the graph. Before graphing, let's do the horizontal asymptote using the chart. So we have m of 2 and n of 1, highest exponents. So that means there's no horizontal asymptote. So nothing to graph there because m is bigger than n. Right, so now let's just type it in. Right, I go back to the original one and type it in with parentheses. All right, enter it in with parentheses and then hit graph. Okay, and so it doesn't actually show up with the hole right here at 4, but we know it's there. Okay, so when I graph, I'm just going to graph that line. Right, I think it crossed at 4 is where it's crossing, and then it's just a linear one. So again, I'm just going to draw it as best I can, like this. And then I'm going to go here where x is 4 and draw my hole. Right, and so even though you can't see it graphically, it's actually kind of interesting. You can see it in the table. If you go second in table, you'll see at 4 there's an error, meaning there's basically a break there. So that's kind of interesting. You can see, even though it shows up on the graph, it doesn't show up in the table. So anyways, the way we mark that on our graph is just to draw a circle there. Go up from 4 and draw the circle. All right, last thing I do want to do is review the other type of question. And I kind of like these because this is a good use of a rational expression. And so say your practice is for the ACT and you want to get 90% correct. You get 15 of the first 20 questions correct. How many consecutive questions do you need to get up to 90%? Pause the video, give this a shot. Okay, so certainly you can guess and check on this. That's certainly a reasonable way to do this. But what you'd essentially be doing is you'd be starting with 15 out of 20, and then you'd say, well, I'm going to get X more correct, right? This is my correct answers on top, but I would also have had to, divide by more questions now, right? You'd have more correct, but you also would have completed more questions. So this would be sort of the setup is add correct questions to the total and to the number correct. Okay, and so the way you do it with an equation is you say that you want that to equal to 90% as a decimal. Okay, and if you solve this, you'll get the number of questions that you need correct. So probably how I would go about solving this is a little bit tricky math, but this fraction bar means divide. So I'd multiply both sides by 20 plus x. Sorry, that didn't show up very good, but it really doesn't matter because on the left-hand side, the whole point is to get it to cancel out with that, leaving you with just the 15 plus x. Okay, and then on the other side, I'm going to distribute that, so that would be 18 plus 9/10 x. Right, now I would minus 15 from both sides, so we get 3 plus 9/10 x, and then we can minus 9/10 x from both sides, so this is 1x, take away 9/10 of an x, so that'll leave you with a tenth of an x, and then divide by 1/10. So if you do 3 divided by 1/10, it's 30 questions. So that's kind of staggering, is that you have to get 30 more right. And just to kind of check it, if we go back and think about it, if we got 30 more right, that would be 45 right, 45 questions out of 50 complete, right? We'd add 30 to both of these, and that would give us the 90% that we're hoping for. So that's kind of crazy. If you start off in a little bit of a hole there, you only missed 5 of the first 20, but to get back to 90%, you got to answer 30 more in a row correctly. So kind of interesting how percents work there. All right, so that's all I got. That's the end of 8.3. It's mostly about graphing, but I think there's one like this on the test too, which is a good use of that's a rational expression, and you can use it here to figure out how many additional questions you need to get correct. Thank you for watching.